Me too.
Yeah, good morning. So now it's 7 a.m. for you, or?
Yeah, just after 7 a.m.
Yeah, so thanks a lot for coming at
You're
such
welcome.
an early hour.
For me, this actually isn't that early. I work a couple of different time zones, so this isn't too strange for me.
Okay. So what time do you usually wake up?
Usually about 4:35,
Okay.
somewhere in
Yeah.
that half-hour range. And I've got East Coast clients, I've got UK clients, I've
Mhm.
got one client in Germany, but we don't really get on the phone too often. I usually interact with their US division.
Mhm.
I've got one client now that's in South Korea, and
Okay.
so I am I'm global.
Must
Sadly,
be
I
challenging.
function in a lot of time zones.
Okay. Yeah, thanks for finding time in your schedule to talk to us
Yeah,
and
happy
share
to.
your knowledge. And yeah, I think we can start.
Yep.
So it's yeah, next time maybe I'll think if I want to do another 5 hours long conference. So it's
It's
and
a marathon if you're the
yes.
host and you're the only one.
Yeah, so I'll think twice next time. And actually, we still have 55 people who
Good.
managed to to stay till the last hour. So these were probably people who really wanted to listen to our conversation. So thanks a lot for staying that long. It must be tiring, I know. And yeah, thank you also for putting that post that went like, I don't know if it's viral for you, but like I consider it a pretty successful post. Like a lot of people noticed that conference because of your post. So I don't know maybe like how many, but like I saw a very high peak of registrations right after you posted. And then the trick you did with like first 45 people get it free, and the rest like this is amazing.
It's funny. We're data scientists. We do all of this type of work with marketing. We build models to help automate marketing. I build models for pricing strategy and decision support. And then you see people online not use it. We have all of this knowledge, and why not use it? Why not apply it to our everyday life? And you can do things that are interesting and fun and entertaining because we've seen the data.
Okay, yeah, so let's start. So
Mhm.
now we have this last talk of today, and we will talk about the key roles and skills for monetizing machine learning. And we have a special guest today, Vashishta. Vin's current focus is monetizing machine learning, which covers revenue pricing strategies, model reliability, and also covers defining and hiring research, architecture, product management roles. And he also covers the path to production. So as you see, Vin is doing a lot of interesting things. Since the topic of today's conference is career, we will focus more on roles, roles that are important for monetizing machine learning. So welcome. Thanks for joining us today.
Thank you for having me.
Yes. Before we go into our main topic, let's start with your background. Can you tell us a bit more about your career journey so far?
Every time I do this, I sound old. I've been in technology in the field for over 25 years. I was fortunate. My mom worked at the university where I lived, and so I had one of the earliest email addresses when I was 12 years old, and fell in love with it. Really did. I had a couple of good teachers in grade school who pushed me towards programming and fell in love with it. Wanted to do machine learning. Went to school, went to college for machine learning during that first boom in the early 90s, and graduated, and no one wanted to hire me to do machine learning because it had all fallen apart by the time I graduated. So I had to go into tech. I had to go into traditional technology roles, and that meant a broad range for my career. I've done everything from install computers, do websites, build networks, all the way out to product management roles. And so I've played a role in every phase of the software development lifecycle, got into strategy, uh, led and built teams. And then in about 2010, 2011, data science again showed up. We got past BI and advanced analytics. And that's when I got back into the field. I didn't know it was called data science at the time. There were a bunch of us doing it outside of Silicon Valley, and we all thought we
Data
had
mining was it
invented
called
something.
back then, or
What's
do you
that?
remember then? Data mining or?
Oh yeah, data mining. We were doing MapReduce. We were using we were using some of the early Google tools, depending upon a lot of the early papers. Even back into the 90s, there were a lot of publications that we ended up using, and a lot of papers and thoughts from the 90s and early 2000s that we ended up implementing. My first client was supply chain. Then I went into marketing, and it kind of snowballed from there. A lot of the early work was me having to convince companies that there was value in gathering data in a more comprehensive way than just BI and warehousing and that sort of thing. And like I said, it just took off. 2015, I had Fortune 100 clients. People were bought in at that point. And I've spent almost 6 years, 7 years almost in strategy for machine learning. Before that, I was published on things like competitive intelligence and competitive strategy. So there's a deep strategy background, deep machine learning and data science background, deep technical background. I got lucky that I got this whole spectrum of everything sort of over the course of this 25 years. And that's what I'm working on now, is helping companies with strategy, helping companies with things like monetization, which we're going to get into, path to production, helping companies understand exactly how to build products and make money and generate revenue. From the technical side, I work in decision support, decision science. I do that for C-suite, for actual strategy creation and strategy planning, as well as some behavioral aspects that work into marketing and automated process, ML-based process improvement. And so it's an interesting field. It's an emerging category. I'm kind of lucky. I'll be
Mhm.
completely honest. I'm really lucky to be where I am.
Yeah, I guess when it just started, all this data science, people had no clue what it is.
Yes.
Uh, yeah, being around that time is really something that like a luxury that people now don't have. Somebody who wants to get into data science, because back then, like nobody had the clue, and then it was probably easier to get into that field. I don't know, uh,
It was
but
interesting. It wasn't easier. The it was easy to be a data scientist. It was really
mhm,
hard to get people to
uh-huh.
pay you to be a data
Okay, yeah, I see, I
scientist.
see. Because it wasn't popular, right? So it
Mhm.
became more popular like maybe 6 years ago, right? 7 years ago, when it kind of boomed. But before that, yeah, yeah, right. Yeah, so maybe I have a few questions about your career, but maybe let's keep them till the end because I really want to get into the main topic of monetizing machine learning. So your LinkedIn headline says, "I monetize machine learning." And I remember when I connected to you on LinkedIn, the first thing I asked you about was, "What does it mean?" So what is that? What do you mean by "I monetize machine learning"?
Well, companies have different levels of maturity when it comes to machine learning. So obviously, I'm talking about this broad spectrum of companies who are either at the very early stages, they have data scientists and they might have some prototype type projects that have gone through the pipeline. They're in production, all the way out to companies that have done advanced machine learning that actually have products that are based around models. And no matter where you are in the spectrum, there's this one common theme. It is revenue. And so companies are starting to look at machine learning and saying, okay, this is really expensive. This is more expensive than we thought. The early companies that are still doing prototypes are looking at it from a staffing perspective. These engineers are extremely expensive. They're now telling me I have to have all these other different types of products to support machine learning. And then you have the very, very mature companies who are looking at the cost to maintain and deploy high-end models, these very, very complex models. They're looking at that cost and saying, this just gets more and more and more expensive as it's in production. So we need revenue. And so from both ends of the spectrum, you have companies saying we need to make more money off of machine learning. So that's the core driver for monetization.
Mhm.
And what monetization is teaching companies, number one, how to become more mature when they look at machine learning. But number two is to create a strategy to handle everything from research and understanding how much value you can get from research, because that's the most valuable thing a company can be doing, is creating research, doing research and creating artifacts from that research, and then using it for project after project, product after product. In many cases, they're defining new categories and evolving the business model in interesting ways. And the more mature they get with research and the more they understand how to monetize research and how to productize models, the more revenue they see coming out of it. And so that's monetization, is this massive, really effort to take the business from toy projects or projects that get into production and then are very, very expensive and the returns sort of reduce over time. Monetization is that process of taking them out of sort of the machine learning dark ages and into a more modern way of using these for products and efficiencies.
Yeah, so as I understood you, just let me summarize it quickly. So machine learning is expensive, right? So first you need to pay people. People are expensive, and especially like we are talking about people with a certain skill set, which is not easy to find, right? So these people are expensive. And then once we get these people, they run all these GPUs, Kubernetes clusters, and things like that, that are also expensive. So expensive people spend a lot of money on expensive things, right? So we need to somehow warrant, like in a way, like to say, okay, we keep these people because they generate these products that bring this amount of revenue, right? So they're not just burning money, but they're doing something useful, right? And you do that by coming up with a strategy of like finding, okay, what should we focus on? What should we do to actually to show that these people are not just burning money, but they're bringing value to the company, right? Is it correct?
Yes.
Did I miss something?
And we can go into a little bit more depth into each one of those areas. I wanted to give you all of the high points, and I think we can kind of explore more of what this means, not only from a business perspective, but also people trying to get into the field. What does this mean for you? What does this mean for your career?
And yeah, so we definitely will go there, but it's interesting to know like how companies can actually evaluate the value that data scientists can bring. And again, coming back to your LinkedIn profile, so your bio mentions that you built and brought products to market with ARR in the hundreds of dollars
Hundreds of
and
millions.
hundreds of millions. Okay,
Yeah, hundreds of dollars they wouldn't pay me very well for.
yeah, but to be honest, like I think this is an important money-related metric. But to be honest, I don't really know what this ARR means. Like, do I even pronounce it correctly? And what is that?
No, you did. That's
Okay.
perfect. We've got an acronym soup and strategy. And, I'm building a strategy course kind of on the side and one of the first things I'm doing is building a glossary, because these terms are, if you're in data science, you're looking at these terms going, what are you talking about? Because we have a totally different language. So ARR, annual recurring revenue, annualized recurring revenue, you'll hear MRR, monthly recurring revenue. These are terms that the C-suite is going to listen to. Like, my profile is very C-suite centric. I look at board of directors and people who are CEO, CTO, CMO in a lot of cases, chief data scientists, who are product focused, who are revenues focused, who are cost savings focused. And so there is this rich acronym soup, just like there is in technology. And it's a different language and a different way of speaking. And you're totally right. If you come from a data science background, there's this translation that needs to happen between things like revenue and how companies measure revenue and how they talk about metrics and how we talk about metrics. And the nice thing about data science and machine learning is we do this. And CEOs like that because they're used to strategy consultants and these large companies and IT services companies who come in, and it's hard to sort of differentiate between what's real and what's not for them. Whereas the data scientists come in and we have data, we have results, we support our results. And so all you have to do really to be successful with the C-suite is understand their language and then convert our data, bring our data into their way of thinking. And ARR, those types of metrics are important to understand because now you're speaking a language that is going to get you budget. And so
Mhm.
that's why that's one of the first things in my profile is I build products with
Mhm.
an expected return,
Mhm.
which is going to be interesting and significant to a CEO.
Mhm.
And also is going to generate budget. I'm going to be able to justify budget to a CEO
Mhm.
because here is the potential range, high, expected, and then underperforming, where they can look at it and say, okay, I'm going to spend 100,000 on this project because I'm expecting at the mid range at least 10 to 12 million dollars
Mhm.
in annual revenue or something broken down monthly if that's how they work.
Okay, so basically, this line in your biography in LinkedIn is targeted towards your potential clients, these
Mhm.
C-level people who find you in LinkedIn and then see, okay, this is the right person because he can bring me that amount of, like, he first of all speaks my language, so like ARR, this is something this person understands, so clearly we will not have any troubles talking, right? And then yeah, I see. No. Um, what are the other important things that people on this C-level, like in high management and top management, in addition to this annual recurring revenue and monthly recurring revenue, what are the other money-related metrics that they care about?
Every company's different. And so you have high level metrics which are important across the board. Revenue and cost savings are your two drivers. Then you start looking at business model. What is the business model? And you're not necessarily looking at a static thing. One of the large sort of themes in strategy right now is this concept of business model innovation and altering the business model for adapting new technologies, including machine learning. And so every business now is coming to terms with that business model innovation and trying to figure out how they're going to change their business model. And that's where you find the core metrics. That's where you find the types of numbers that are interesting to the company. And I say that this is a dense acronym soup because it really is. In every business, you'll find businesses talk about strategy differently. Some, when they say strategy, they really mean tactics. There are some businesses that are just immature that way. And that's not a bad thing in every case. Some companies are so focused on execution, especially at a very, very young phase or a small company, that their needs for strategy are just as big as any other company, but the maturity just isn't there yet simply because they haven't made it. And so you have an entirely different range of tactical focused metrics for those companies. Whereas a more strategic company is looking at a bit more of a long term view. They're looking at their product roadmap. They're looking for efficiency type products, which are going to reduce the costs of doing business, which is going to give them a competitive advantage. You're also looking at revenue streams, increasing their current revenue streams by acquiring new customers, producing new products that may create new revenue streams, pivoting their business model. And you're kind of hearing now, I'm getting more and more and more specific.
Mhm.
And I'm going from the strategy realm into more of our realm when we start talking about products and building models that are going to line up with their core business metrics. And you really have to look at when you're in a business, what do they care about? What are they talking to investors about? The numbers that are important will almost always be in their quarterly reports.
Mhm.
That's a really quick and easy way to understand the business that you're in or a company that you're potentially looking at being hired by. What metrics are they explaining to investors? What are they talking about in press releases? Those are going to be the core numbers that they're most interested in. And so that's how you quickly understand the metrics that are important to them. And then you can start thinking, okay, is this a data science problem? Is this a machine learning problem? How do I now translate that into my language? And then using their language, using these specific metrics that they talk to others about, now I'm going to say my project can do, my project can improve, my project can change. And you can start talking about it from a business model perspective or a current business model perspective and the metrics and goals that are important.
Mhm. Yeah, I can immediately see how being able to speak this language and translate this, okay, now I have a model with AUC 90% or whatever, to this ARR of some
Mhm.
other number, like this skill is something that is really valuable to convince the people who are actually in charge of money to give more money, to give budget to the machine learning team, right? If you don't convince them, if you fail to convince them, they will not invest. They will not invest money in the team, right? They will say, okay, I don't understand what you're doing. I don't see how important it is for our business. Then, yeah, maybe we should spend this money on marketing or something else, right? Uh,
Right.
then, like, what's the point of keeping these people here, right? And yeah, coming back to our main topic of monetization roles. Um, so, who should we have on the team to make sure that the projects we're working on, they're successful and monetizable?
There are three real main areas that I focus on. We've talked about strategy. So you need someone on the team who is a strategist, who speaks both languages, kind of straddles both worlds. You need someone who understands, like we've been talking about. We have this language of business, which is very, very revenue focused, very, very cost savings focused. And then we have this language of machine learning. And you have a role that is a machine learning product manager, where this person is sort of the crossover with a strong strategy background, but also a strong machine learning background. So you need a machine learning product manager. Like we talked about also, we mentioned research being
Mhm.
such an important part of realizing revenue, creating competitive advantages, building a company that understands not only machine learning, but how they're going to make money off of machine learning and how they're going to change the business model in order to start leveraging machine learning instead of constantly keeping up and trying to chase after companies that are bringing out market share, that are stealing customers away from them. And that's where the machine learning researcher comes into play. And you've got two different types of researchers. You have applied and you have science. The more mature a company is, the more they're going to go into the science side, the
Mhm.
true hard science research. Applied research is still scientific. You're still making breakthroughs, but it's very, very focused on building. Like I do applied research. I don't have a PhD. So I could do science, but I'm not the right person to. And that's also important when you look at these roles. A machine learning product manager could spend a lot of time building models, but they're most valuable because they also have that strategy side. A machine learning researcher, as an applied researcher, I have more value because my science focus, I have it, but still I'm far more valuable because I understand how to apply research and how to take something that's new, build it, and make money with it. You also have a machine learning architect, which encompasses the data engineering, machine learning engineering, and a lot of these roles, but they're more front end. They again have a almost strategic role, even though they're very, very hardware, very technical, very software development focused, along with having strong machine learning skills. And so you have these three capabilities in three roles who are going to speak to the C-suite, create a connection between research and strategy, and that's your product manager. Then you have your researcher who's going to take that understanding of what the business needs, what kind of lines up with the business model, and start creating research that results in artifacts that the company can use over and over again. These become intellectual property and can be reused from project to project to project and drive new products, new revenue, new efficiencies for the business. And you have the ML architect who's going to sort of create part of the product roadmap that explains exactly how expensive some of these projects are going to be. And as part of that, your researcher is also going to adopt their solutions, because some solutions are viable but way more expensive than
Mhm.
other solutions. And so that sort of drives research from a more applied and practical standpoint, because your architect's going to say, look, yes, you can do that, but in a year, this is going to cost 5 times what, maybe you can figure out a better approach because this is going to get expensive.
Mhm.
You roll all of those roles together, and you now have this front of the process that's connected to strategy that is going to create a product and a competitive advantage for the business. And now your more traditional roles downstream can be far more effective, because a researcher is going to hand these artifacts off, and your data scientists and your machine learning engineers now have a solid framework to begin from. They have a solid product from the roadmap. They have requirements. They understand the connection between the business model and what they're building. You have ML engineers who have a long-term framework that they're building out. What does this platform look like now, and what do we need it to look like in 2 years? Where is it going to go? How is it going to scale? What are we going to support coming up in the next couple of years? And so what kind of considerations do we need to have? And you hear this more mature way and far faster. You build models and get them into production at a far faster cadence because you have these upstream roles. And that's a big part of monetization, is making sure that these projects aren't wasted money.
Mhm. Yeah. So just want to make sure I understood. So like you mentioned three roles. So you mentioned machine learning product manager, so somebody who thinks about strategy and knows how to apply knows machine learning. Then machine learning researcher. There are two kinds: applied and scientist, somebody with a PhD. And then we have an architect, machine learning architect, who like can say, okay, this is too expensive, and just thinks about implementation. So this like an artifact from the researcher, and this is how we can bring into production. So we have three roles. And then in addition to these three roles, we also have more traditional roles like data scientist, machine learning engineer, maybe data engineer, right? And so if I understood you correctly, so we already, let's say we have a team, we have data scientists, we have data engineers, we have machine learning engineers. To be better at monetizing their efforts, their projects, we need to add three more roles to the team, or maybe somebody in the team can perhaps play these roles, right? So this is like something in addition to existing team, we can add three more, I don't know, not people, maybe three more roles, and then we become better at explaining how we earn money with machine learning, right?
Right. Yep.
Yeah,
Yeah, I say
maybe.
three more capabilities,
Mhm.
but
Okay.
that's perfect.
Mhm. And then let's talk a bit more about this first the researcher, machine learning researcher. So we have applied researcher. We have yeah, maybe let's talk about this person, applied researcher. So what do they do? So you mentioned that they produce some artifacts, and so what are these artifacts? What do they produce?
So the two main artifacts are your model, and research is really poorly understood within the data science community. And you have your applied researcher and you have your science researcher. And so on two sides, your main artifacts are your models and your data sets.
Mhm.
It's really important to understand that a novel data set is just as valid an outcome of research as a new approach or a more accurate model. And what a researcher will do, whether applied or scientific, and you have to sort of parse these roles based off of where their focus is. A science researcher is more interested in creating an artifact, whether it be a model or a data set, that does not have a specific application, but it simply lines up with the business model or a potential business model, a pivot for that particular business model. And it takes a more mature company to understand how to evaluate research, pure science research, about some part of the business, because essentially what you're modeling is some piece of the business or some interaction between the business and, say, customers, competitors, some other portion of the market. It can be something like a supply chain. And that's what's being modeled. A scientist is going to do a pure science project, obviously with data, with machine learning involved in it. But what gets created, the business is going to have to look at those artifacts and say, okay, now how do we turn these into products?
Mhm.
That's why it's a more mature business, because in many cases, you're creating a new category. And in machine learning, this happens all the time. New categories of product or just new categories in general are being created. The company then has to define that category and figure out how to enter that new market or expand into that market if they're already in it.
Uh,
Your
what kind
applied
of category?
researcher, what's
Like
that?
I'm just thinking like what kind of like maybe you have an example, like what kind of category would it be? Let's say if we take Amazon or Google or some,
Mhm.
like maybe let's say Google wants to get into a new market, let's say develop a new product. Would it be a category or?
For Google, they're going in two different directions. They are creating categories, and I don't think we've seen Google has a lot under the covers
Mhm.
that we just don't get to see. We see these small pieces of it in their open source offerings and in
Mhm.
some of their papers, and so we don't really know a lot of what's going on under the covers. They've looked at things like healthcare. They've looked at finance. Or fintech. They've looked at a lot of different spaces. Amazon's the same way. They just kind of abandoned healthcare. I don't think healthcare is really ready
This is
from
a kind of category, right? So
yeah.
let's say Amazon wants to get into healthcare, and healthcare would be a category, right? And then
Mhm.
there could be a researcher, like a scientist, somebody with academic background who can think, okay, I know what are the goals of the company, right? I know what is the business model. I know what the company wants to do, and this is the area where the company wants to do. And the task of a researcher is to figure out how they can do this, right? Like experiment with
Well, how
different
to do
things.
it in a different way? Because in a
Mhm.
lot of cases, you're entering a crowded field. Fintech's a crowded field. Healthcare is a crowded field. And what you'll see companies do is kind of two things. And I bring up Amazon because they killed a project. In a lot of cases, this is what happens with science. You have to have a company that's mature enough to monetize science and real data science research, the big R type of research. And in some cases, that means killing projects because you get to the end of the road and there's just been nothing produced. There's nothing valuable. You can't find anything to productize or monetize. And so you try to expand into a space and you say, okay, this was a failed experiment. But the company understands, because they understand monetization, that that little failure is worth it. Because if they do 10 failed projects and one of them is a success, the ROI of that success is huge because now they're entering a new market. And so, what Amazon was trying to do was figure out if they could define a new category within healthcare, and they failed. Whereas you see in other cases where they, went into services like AWS is a great example of them creating a new category where
Mhm.
nobody was there
Mhm.
before this. And now they've also created categories around machine learning and your ML ops. They were one of the early sort of providers for ML ops type software. They created a category, and now you're seeing a lot of people rush into that category. And that's more of your applied researcher side of the world, because there wasn't really a whole lot of science to do there. It was simply Amazon looking at a problem that they had in house and saying, "Oh, a lot of people are going to have this problem. So now this is a product." And so that's your artifact for an applied researcher, is someone
Mhm.
who's looking at a new category and saying, we can actually build this because we already have it. And we just need to scale it and offer it up to offer it up to customers.
Mhm.
You've got a PDM who's going to say, this is the business model, this is the business model we could get into, and this is the pricing that we could support. And again, it's that strategy side overlapping with research. And when you talk about creating a new category, now you're talking about a product that maybe has never existed or can't exist without the model itself or without some sort of machine learning
Mhm.
driving and running it. And that's what you're looking at when you start talking about new categories and
Mhm.
defining categories. It's something like Uber. Without
Mhm.
machine learning, it simply wouldn't be as efficient as it is. And the same thing with a lot of these new online startups. They're creating new categories because they can use machine learning and they can monetize machine learning as a core piece of their business model. The machine learning first. That's
Mhm.
where a lot of the research piece comes into play. And that's where defining a new category as a result of machine learning comes into play. And those are the artifacts that you see when
Mhm.
you look at a Stitch Fix, another great example of a company which is machine learning first and creating a new category. That product existed in the past, but not in the way that they've been able to redefine it. And so they have redefined the category and entered a new market because they have that machine learning there.
Mhm. And what about companies that are, let's say it's a small startup, they just appeared, so like not as ambitious, like they don't want to be second Google, they don't want to be second Amazon. They just found a small niche. They think they can make a difference in this niche. Uh, so how about them? Do they even need this kind of role for them? And if they need, like maybe, I guess they also need to be at some point of maturity to think about this role, right?
Mhm.
Or it's different.
What I say this a
Like,
lot. Angry users and data scientists create startups.
Mhm.
Because in a lot of cases, that niche that you're talking about, it's a niche because there's no product there.
Mhm.
And you have an angry, passionate user base who's saying everything we do is bad. Everything we have is not a solution to my problem. This just doesn't work. And you have this very, very angry user base angry user bases are willing to spend money. And so if you can, as a data scientist, pair up with an angry user who really understands the need, who has a connection to that market, who understands a lot of the business side of how you would get into that market, what the product would need to look like, what problems it needs to solve, who the most passionate people within that problem group, within that angry user group are. And then you have a data scientist that looks at it and says, oh yeah, I can solve this problem. This is a machine learning problem and I can create a novel solution. Even in a startup, those two people by themselves can create and define a new category for everything from a niche to a massive market. And like I said, that's how the best startups are founded, is an angry user meets a data scientist and they get together and have a bright idea and build something. And if you, even as a 2 to 5 person startup, can do that and can tap into a market and understand how to define that new category, you can make a lot of money. And the machine learning researcher is your first or second hire. They're a
Mhm.
co-founder.
Okay.
So big, small, it works across the board.
Mhm. So yeah, so basically this capability of machine learning researcher, so it could be a data scientist, right? So it doesn't have to be somebody coming from academia with all these, publications at top conferences, PhD. It can be just a simple data scientist who has experience working at different startups, who knows how to process data, who knows how to, I don't know, train a scikit-learn model. Am I right? Or there are some other things that, let's say, an average data scientist needs to become to wear this hat of ML researcher?
An average data scientist, I think, would kill the data science job title and
Okay.
try to spread it, across. It's like peanut butter, and we're trying to spread it across a 10-foot wide piece of toast. It just doesn't. We can't do it anymore. And so when I say researcher, I mean someone who understands research, the big R. In software, you used to have this concept of big R research,
Mhm.
which now in machine learning is a whole lot more applicable because there's real research that needs to be done. There's experiments that need to be done. And I talk about this process where you start out with data. It's data you can't rely on. It's garbage. It doesn't truly represent what you think it does. And that first model that you build based on that data is a hypothesis. This is how you think what it is that you are modeling actually works. This is best guess. And depending upon how well you can support that hypothesis, you should either go forward and keep working that direction, or maybe go back and rethink things, gather data in a smarter way based off of what's wrong with your initial hypothesis. That's research. And now you create an experiment to, once you have something that's solid, once you have a hypothesis that you can support, that initial model is something that you can support with data, with performance. In some cases, you test it alongside something else in production and you say, I see an incremental improvement here. I see something interesting in this particular model. And that's where a lot of the automation software and workflow automation software comes in, is taking your data, creating multiple models based off of it, and then displaying information to you as a researcher where you can look at it and say, that's okay, that's interesting. That right there is interesting. And now I want to pull that model back and understand how that model works, because there's something about it, some piece of that model's functionality. And this is where you get into explainability and sort of deconstructing your model to understand how each feature works in order to create a better outcome. And typically these models reveal something about a system that you didn't understand from the beginning. And so that initial model that you create based on your hypothesis, and maybe this iterative process that you do as secondary, tertiary hypotheses, you now go back and you say, okay, there's something interesting here that I've discovered, and that's research. And you create an experiment to either sort of refute or confirm that you found something interesting. And that model is now giving you data about the thing you want to actually model. That hypothesis and that experiment and the results, that's research. Now I've gotten some sort of tangible result about what it is that I'm trying to model. And so I have a better understanding of what data I need to gather. I have a better understanding of how my next iteration of model should look. I have a better understanding of an additional experiment to now discover more. Is there more here? Is there more to go into and understand how this particular system works based on my discovery? And this is what you find a lot. This is the iterative process of research. Most data scientists don't understand this. They're stuck in statistics. And you hear this a lot. People who talk research will have people say, "Oh, you don't understand statistics." And it's like, no, you don't understand research. It's not all statistics. Yes, we use statistics heavily. It's a heavy part of research and experimentation and exploring your data and understanding your results and trying to support them. But that's not everything. There's way more to this. And sometimes the statistics pushes us away from actual research. We get statistical results and statistical models, but that takes us away from the thing that we're actually trying to model and simulate and understand. And so that's the research side of this.
Mm-hmm.
Anyone can be a researcher. I mean, I don't have a PhD. So anyone can get into the research side of this, but you need a strong, solid science background. And the only way I got it is early on, my models got destroyed by hardcore scientists. They looked at my models and they said, "Okay, you've supported them with statistics. Here, let me destroy your model now, because you're not using any of the metrics that really matter. You're not modeling anything except for the data. All you've produced for me is a representation of the data in a different form. That's worthless." And I got taught the process by some very, very smart and somewhat abrasive people who gave me honest feedback. And that's what it takes to get into the research side. That's what it takes to move from data scientist, which, like I said, it's kind of overextended,
Mm-hmm.
into a more rigorous research role.
So it's more like a mindset, right? So like as I understood, so what the researcher needs to know is they need to be able to come up with hypotheses. They need to be able to test these hypotheses, to verify them or reject them by experimenting. They also need to be able to do some sort of data analysis. First of all, to understand that the data is not garbage, but then also understand the results of like kind of the drill, go into the results of the model and understand, okay, why the model is behaving in a certain way, and explain why the model is doing that. And these are the core skills, right? And then the main thing is the mindset. Okay, I have a hypothesis. I want to test it. I want to try to verify it or reject this hypothesis. And this is where statistics also kind of comes into
Right.
play, because this is one of the tools you use to actually to reject a hypothesis, right? Or
Yeah.
to verify it. And then
Well, and this is
also
where
this.
more of the advanced math comes in too.
Uh-huh.
People ask why you need to understand differential geometry. Why do you need to understand topology? Why do you need to understand some of these deeper concepts around graph theory? In some, you can get very, very niche with the type of math that you need to understand in order to explore your data, in order to come up with experiments. And that's part of the skill set, is really understanding how to creatively build an experiment that's feasible, affordable, and then will probably get you the results that you're looking for, get you a better understanding of what it is that you're trying to model. So it's not only a mindset, it's also a skill set. It is a capability to do more of the science side of the field.
Yes, we also need to cover. I just looked at the time and noticed that we still want to cover the other two roles.
Mhm.
And we already talked about like this niche, angry users, and pairing with data scientists. But I guess this is where the role of a machine learning product manager appears, right? So this is somebody who can actually, correct me if I'm wrong, but I'm just making an assumption that like when a user talks to a data scientist, they do not necessarily understand them, right? The data scientist doesn't always understand that. So this is one of the things that a product manager does. But I guess there are other things that they do. So maybe you can talk a bit more what kind of work they do.
So the product manager is going to have to address a wide range of audiences. And this is one of the reasons why they need to also have a machine learning skill set. It's because they have to speak to a machine learning team and convey to that team. And sometimes it's a researcher, sometimes it's an architect, sometimes it's your more traditional R&D and dev machine learning teams, your model development teams. They have to speak to them in their language. They can't be speaking in sort of this abstract, fuzzy type of language. They have to speak about models. They have to be able to understand it. But then they also have to be able to talk to users to get requirements and to make sure that the users are able to articulate their needs, because most users can't do that in terms of a machine learning solution or a data science solution. They don't understand what's possible. And a big part of what the product manager does is tells the C-suite, this is possible. I listened into your strategy planning and I heard 3 or 4 different problems that I've done a little back end work and built you a very rough business case. And this is exactly what I think we can do in order to solve some of these problems using machine learning. And now what I need to do is give it to a researcher to prove that we can actually do this. And that's where the ML architect and the ML researcher come into play, is that product manager has enough understanding of user needs and user requirements and strategy, listening in again to the planning process, hearing business problems, hearing goals, and being able to then write a business case saying, with my knowledge of machine learning, I'm very sure that if I give this to a researcher, this is something that we can solve better with machine learning than we could with a traditional software approach or whatever we're using right now. And that's the product management role, is being able to be that translator, create the initial business case, frame and reframe the business problem, gather requirements and work with users sort of through the whole life cycle, and connecting all of these other groups into the product development process, and then passing all of this over to the teams that are going to be responsible for researching it, architecting it, and actually building, deploying, and supporting it. And then also create a gated process where that PDM is reviewing at gates, at particular checkpoints, or at achievement points. I'm trying to define this a little bit better.
Management sort of thing, right? Like basically making sure that the project gets delivered.
No, that's one of the key differences. The project manager is making sure the timeline's in place. The product manager is making a kill or green light decision where they look at the progress with respect to the business. Is this returning the value? Is this worth investing more money in? It's almost like in academia, you have the grant and funding process where you sing for your supper every quarter or every year to try to get more grant money. And the product manager is really the one who evaluates whether I should continue as a business to fund you, whether I should go back to the C-suite and say, yeah, this is worth another X amount of money because we've made tangible progress. Here's what we've built. Here's what we've done. Here's why I think we should get funding for an additional round of research, or why I think we should put it on the roadmap, the product roadmap, and go forward with it. And so they're in charge of that gated process, not so much deadlines, but deliverables.
But that's a lot of responsibilities, right? So they need to talk to a user and translate the requirements of a user, like translate whatever user is saying to a bunch of requirements, to a set of requirements. Then they need to work with researchers and kind of help them. Well, first of all, they need to know like if it's at all possible to solve it with machine learning, right? Even before talking to researchers. Then they need to talk to the researchers and translate the needs of a user to the researcher. And then they also need to talk to the C-level people and then translate this whatever researcher did in terms of like, I don't know, they maybe did some machine learning, and then they need to come to the CEO and say, okay, this should result in whatever letter soup like metric, like ARR or MRR or something else that the company cares. They need to know all that. Am I correct?
Yes.
That's a lot of things. Like
product manager is, even in traditional software development, product managers they're the apex predators of, of the business world, because they are engineer strategists.
Yeah, it's like one single person, or maybe like it feels like a team of people doing that.
It can feel that way. The way that it ends up working is you have a product manager who has all of those core capabilities, and they'll rely on, there's a traditional requirements team. You'll have technical writers and requirements gatherers, business analysts who do the requirements gathering, but they need the product manager in order to guide them and help them understand what requirements are they actually gathering. Have they been written up correctly? Have the user needs actually been captured? So they're not personally writing up the requirements. When they write up a business case, a lot of that business case is already there. Other groups that are interested in solving that problem have presented a lot of the background research, have done a whole lot of the legwork around the business case. And now what the product manager is really defining is, how are we going to use machine learning from a proposal standpoint? This is how I propose us to use it. And now they're giving that to a researcher and saying, hey, is that, am I right? Is this something that we can really do? Did I nail it here? And the researcher will typically then have this little bit of funding from the C-suite who've seen the business case, who've seen this proposal, and said, yeah, I'll give you some funding to do a 2-week exploratory on this. And then the researcher will come back and it'll be basically a feasibility study. Is this something you can do? Do I think that you're right as a product manager? So you're right, there's this ecosystem around the product manager, and the ML architect gets involved as well, because they're looking at that proposal and feasibility study from a path to production standpoint, from a support standpoint. And then you've got another layer of, well, yes, this is a brilliant solution. Great job, scientist, but here's what it's going to cost. Here's what it looks like if we actually put it into production. And so you're having a lot of different roles being relied on in order to support your product manager. But yes, the product manager has a significant skill set and a very deep understanding, not only of the technical side, but also of the business side.
Yeah, and basically they need to be able to communicate with people who are collecting requirements, who are building the models, who are, I don't know, like this ML architect, for example, and they need to be able to speak the same language with them. And if need be, they also can go ahead and do this themselves, but they typically don't, right? Usually they are like on a higher level and sort of more coordinating than hands-on. Right.
These are typically former data scientists, former ML engineers. They come out of that, but they've also spent enough time. A lot of them come out of startups, because in a startup, you're really forced to do product management and also data science and machine learning and a little bit of research in there too. And so you'll see these people coming out of startups in a lot of cases because they were forced to be unicorns, and they have just enough understanding that they can quickly be upskilled within the business to do a larger range of activities. And so the product manager is not necessarily going to be the person that builds anything or prototypes anything. They're simply going to present the problem in data science and machine learning terms, so that a researcher, more than them telling researcher, hey, do this, it's more the researcher telling them, okay, based on what you told me about the problem, I think I can do this, and here's my proposal. And again, very similar to an academic model where they say, here's my proposal for what I'm going to do research on. What do you think? And the product manager can then talk to the architect, who says, okay, based on that proposal, here's what it would take. Here's what I have to build in order to support this long term. Here's the architecture and infrastructure I'd have to build. What do you think? And now the product manager goes back and handles that ROI calculation. So it's really them talking to the product manager. The product manager is doing a translation to machine learning terms and data science terminology. But at the end of the day, it's technical folks driving that conversation about technical topics. So the product manager isn't the sole technical owner of this. They aren't the technical lead. They're the business lead. But like I said, they have to understand what the researcher, the architect, the developers, and the engineering side are telling them. That's why you have to have the skill set.
So you already mentioned that. So that usually data scientists and machine learning engineers become these product managers, and typically they come from startups. But can usual product managers that work in IT companies, they probably also have quite a good background to kind of become machine learning product manager, right?
I've seen people try it with mixed results. And depending upon how technical the product manager is,
okay, so they have
and
to
what
be
their
technical.
background is, sometimes you'd be surprised. Somebody with a background in economics does very, very well in the machine learning world, because like I said, you'd be surprised how much you learn that relates to machine learning from an economics background, from a hardcore econ background. And so there are success stories depending upon what the background of the product manager is and how deep they got into their, the technical side of it, understanding the platform, but also understanding it from a science side and from a model development side. So you can upskill a product manager into a data science, machine learning product manager role, but it really depends on their background. In some
Mhm.
cases, project managers become product managers. They're semi-technical, and it's really understanding how well they're going to learn the data science and machine learning side that will determine whether or not they're going to be successful.
Mhm. Yeah, like I noticed that this product manager person, like he kind of is in the center of like the communication hub in a way.
Yeah.
But then like there's also this machine learning architect that um, we didn't talk in details about. Like from what I understood so far, so this is a person who can like who looks at the proposed solution and then kind of first of all can understand if it's possible to implement it all or not. And then if it's possible, they can also attach a price to this. They can say, okay, like if you want to go with this model, this is how much it's going to cost you, right? And then they
Mhm.
can say, okay, this is too much. We probably need to do something simpler. And then they come back to maybe to researchers and say, yeah, let's do something simpler, right? Did they get it right? Or?
Oh, it's absolutely correct. The way that an architect provides value is creating the larger vision for the platform
Mhm,
based on the business needs, and then the platform becomes part of the product roadmap.
mhm,
That's the really important piece of what an ML architect does. And you see this in cloud architecture, you see this in software architecture as well. This concept of creating platform to not only enable development, so that we've automated as much of the development process and the research process and the experimental process as possible, but also now we need to create a path for this model to get into production and then be supported. And the ML architect understands platform well enough to say, okay, I'm looking at user requirements, I'm looking at business requirements, I'm looking at customer requirements, I'm looking at what we have in production right now and what platforms we have in production right now. I'm looking at the scale of data that's being proposed from a research standpoint, extrapolating out exactly what this would look like in the real world. How much, is this streaming, is this batch? What do we have right now from a platform standpoint that can support this internally? Do we have something another team is using that we can repurpose? Do we have infrastructure already built out for this? Can we do something on premises, or does this need to go to cloud? Is that even feasible? Because you have an architect who's going to say, look, yeah, it's nice to say we're going to go to on-prem, or we're going to go to cloud, or we're going to go hybrid, or we're going to implement Kubernetes, or we're going to implement, it's great to say that, but now let me tell you what it's going to take to actually do that
mhm,
and how much it's going to cost. And when you start talking about it's in production, what is it going to cost to maintain this thing?
mhm.
Because a lot of models are very, very cheap to make. And after 3 or 4 months in production, they have to be continuously retrained so much
Mhm.
that it's too expensive,
This hidden
that the
technical debt,
research
right?
needs to mature to overcome the problem of retraining, to actually build a more efficient model that performs better on the classes and the regions and the scenarios that the business is most interested in. And again, back to the product manager, they need to define that so that the researcher and the architect can do their job.
Yeah. So what the skills they need to have is they really need to know well the tools. So probably they need to know cloud. They need to know like what are the other tools, and then knowing the scale of the problem, knowing the requirements, they can come up with a suggestion. Let's say if we use cloud, and we can go with AWS or Google Cloud, and then these are the services from AWS that we can use to solve this particular problem, right? Because we need to build this data pipeline, we need to store this data somewhere, we need to then have this machine learning platform that makes it simpler for the researchers to deploy their models, and then they basically take care of all this tooling that makes it really easy for researchers to roll out the things to production, right?
Well, and give it to the model dev team, because you
Mm-hmm.
have your research team at the
Uh-huh,
front end
okay.
of it. They're going to create artifacts, like I said, and those artifacts are going to go to a team who's going to use them to create products that, for sale,
Okay.
for efficiencies that make things in the business run better.
Mm-hmm.
And so the ML architect understands, cloud architect is a very, very good sort of traditional role to look at and say, okay, very similar,
Mm-hmm.
but more focused on the machine learning side of cloud architecture. And in a lot of cases, the business already has infrastructure in place. And so the ML architect is looking at the infrastructure that's in place. They're not necessarily designing from scratch in every scenario. They're looking at what's in place and they're saying, okay, what do we, what can we repurpose to do what we need to in order to support the products that could come out of this research? Is there do we have to do anything? Can we just deploy on what we have? What is it going to take for the team responsible for deploying this to rebuild whatever it is that we may be incorporating into from an existing product standpoint? What are we going to have to do in order to support it? What's new that we might have to do to support it? And in some cases, they'll make a buy decision. Well, they'll say, okay, we need platform, but there's a couple of product solutions out there and we can buy and it's cheaper. And if I look at the roadmap, this buy will also support this product, this product, this product, and this project. So, right now for this project alone, it wouldn't make sense, but we're going to have to do something for these 3 other projects anyway. So now it's justified from a cost standpoint. That's why the architect's important, because the architect can look at a longer term vision and say, yeah, this seems expensive today, but over a year, over 3 years, this is going to seem a whole lot more reasonable and we're going to have to go this way anyway.
From what I understood, like talking about all these 3 roles, researcher, architect, and product manager, all these like people who perform these things, wear these hats, they are quite experienced already, right? So they probably worked already like as cloud architects, as software engineers, as product managers, as machine learning engineers. So, and then this is like they have to be pretty experienced to be able to do these sort of things, right? Or like, can somebody like, let's say, a fresh graduate come and start working as a machine learning architect? Probably not.
I don't believe somebody without experience. It would be like saying somebody without experience could become a software architect. Maybe, I don't think so. Or cloud architect. Maybe, I don't think you can really step into that role. You can step onto an architecture team.
Okay.
You can walk on as someone who's part of the team, who's a junior level person on the team, who's more hands-on, more like a machine learning engineer or a very junior machine learning engineer, especially if you have a software development background or some other type of architecture background and you're upskilling into the role, you can be very, very successful, because a lot of software engineering best practices are finding their way into machine learning engineering, machine learning architecture, and the more traditional sort of what falls under the better known data scientist, model development type of roles. And so you can be successful coming into one of those teams and being a contributor pretty early on, but you do have to have some experience with architecture, software development, best practices of software engineering, and eventually transition into the ML architect role. It's not something that you should be pushed out of or that you can't upskill into, but it's a longer journey. Same thing with the researcher.
Yes.
It's not something that a data scientist can't do. You can come out of a master's or PhD role having some experience in academia, doing publications, or just doing applied work, and transition into a researcher role. So you can be successful coming out of academia. You can be successful coming in from a research assistant or one of those types of roles. It's not necessarily barricaded and exclusionary, but it's a longer learning process than you would expect for something like a data scientist, who you can train up pretty quickly.
Yes, indeed. And we talked about the posts you made, like when you made the announcement. And one of the things you wrote there, that data science programs are still teaching unicorn curriculum and producing people with 6 inches of depth across 6 different roles. But the data science and machine learning field is changing. So most courses, certifications, and programs are 2 years behind. And yeah, I'm wondering, like, it made me think, like, when I read this, like, what can actually universities do to address this? If anything, can they do anything there? And what to do about this mismatch of what we study and these 3 roles we talked about? Because they are pretty hands-on, right? So you cannot just read the textbook and go work as an architect, right? So like you,
Right.
you have to put a lot of effort. So how can we bridge this gap, and how can universities help us?
I see 2 routes to it. Internal to companies, a we don't look at the role of business more or as much as we should. Businesses should be sort of mini universities, and many are trying to, where there should be a pipeline of talent. You should have a farm club as a company where you are upskilling people who are in roles where they may become obsolete very, very soon, which in many cases, the data science team and machine learning team are working to automate. And these are efficiency projects where the company is looking at automating something that's very, very expensive and trying to become more competitive and more efficient. Those people that are in those roles are domain experts, have a lot of expertise within the company. Some may be semi-technical. I mean, every role now is in some way, shape, or form technical. And so there's the potential for that person to upskill. And I think we have to create a farm club and a path for people that are in roles that are losing value, that are going to become increasingly more automated, and create a path for them to go into these more technical roles. And so I see companies having a role in this because for them, it's far cheaper to upskill and take people and improve their employee lifetime value. We think of customer lifetime value a lot, but you can do work to improve someone's employee lifetime value. And now instead of consistent turnover and all the costs that are associated with finding new talent and firing and laying off existing talent and losing all that institutional knowledge in the process, you can preserve that knowledge, reduce those costs, and transition people into these roles. And so that's one of the key things that we can do is as businesses become more like universities and more like boot camps and try to continually upskill and reskill the people that are already there. That is by far the least expensive way to keep up with these ever-changing needs in the field. From an academia standpoint, it's very difficult because universities are trying to become more and more connected with businesses. They're trying to create partnerships, but they haven't really gotten very good at that. There are some, standout universities, which obviously MIT, Harvard, the big names in data science and machine learning. And you can look across Europe and you find a lot of these companies that are now lining themselves up with universities and research programs. Same thing in India, China. There's a lot of countries now which are their core industries are getting very good at partnering with universities, but it's a very small number of universities that are getting these partnerships, and they're only getting the top, most prestigious universities, and we can't have that. We have to have a more accessible educational system. So we have to have smaller colleges, even down to community colleges and high schools. We need to be recruiting straight out of high school and into programs where the person is recruited into a company. And, when I talk about a farm club being a huge part of this, that recruiting out of high school becomes sort of the beginning of the talent pipeline, the beginning of that farm club. The university is involved, boot camps can be involved, sort of this new paradigm of learning and education that is outside of academia, that is purely online and more self-driven and self-directed than classroom and teacher-driven and directed. And this is why I say we need to get into the high school level, because if we're going to achieve any of our goals of education, we have to redefine the way that we teach at the high school level and even the middle school level. We have to be teaching people not for college, not for memorization, not to take tests, but to be productive and to eventually, with the path being, eventually this person is going to start a business and create new value for the entire marketplace. And so that's the redefinition that we need. And it needs to go all the way down into middle school. We need to be getting to the point where we're recruiting out of high school the same way a baseball team does, or the same way a basketball team or a soccer team does, where they'll have a draft and they're pulling people out of high school. They're looking at people in high school, and they're so engaged in the athletic programs and the sports and in the after school programs. We need companies engaging at the high school level and the middle school level in the same way, where they partner with schools and they make this more accessible, because they're going to, as a company, improve our quality of education system across the globe and help transition from memorization and test taking, which even the best education systems are still focused on answering questions that are true, false, multiple choice, writing essays that don't really have a whole lot of substance behind them when it comes to being a creator, when it comes to being a thinker. when it comes to creating value from here up, not with these. And we don't need these. We're automating these. We need these. And that's where the education system as a whole needs to be overhauled in order to meet not only these needs, but really we need entrepreneurs. We need people starting businesses. That's our future, because if we keep creating employees and people who are good at memorization, they have no future in the economy in 10 to 15 years.
And basically, so what you're saying is universities shouldn't even attempt to catch up with the industry, right? So like they should focus on fundamental skills, help people learn things faster, and then let the industry take care of, uh, getting people with this sort of skills, people who can learn fast, people who know the fundamentals, let's say maybe computer science fundamentals, and learn everything that is needed, right? So like this is what universities, they shouldn't try to cover everything. They shouldn't try to cover data science because it's outdated anyways, like it's behind 2 years.
What universities used to be, and they need to be again, is places that build on the body of knowledge. That's the point of a university, is to add to the body of knowledge, to do the research that creates ideas that can be disseminated out to businesses. And so this concept of business dynamism is something that a lot of economists have been looking at from a policy standpoint going back to the 80s. Businesses are not as dynamic. They don't have the dynamism because ideas are no longer coming out of academia. They're no longer state funded. They're no longer country funded. They're no longer funded by research grants from companies to add to the body of knowledge and then disseminate that to all companies instead of just one company. You're seeing that a lot happening with Google. And the reason why there's so much consolidation of intellectual property and so much consolidation of wealth is because we don't have this business dynamism. And so colleges and universities need to go back to being people as part of this organization now adding to the body of knowledge. That's the fundamental piece of all of these theses and all of this research and all of these grants and all of this. That's what that's what a university needs to evolve back into. They almost need to devolve. They're not factories for test taking. These are, when you look at liberal arts, a lot of the arguments for liberal arts degrees are they're focused on people learning how to think, learning how to be creative, and to look at issues and look at broader implications. And as engineers, we should be, and we are in most cases, forced to take courses that are liberal arts courses. And the reason for that is because those are the ones that teach us how to think. Those are the ones that make us look at history and understand broader perspectives, see patterns, and become more useful because we know how to think. And that's where universities need to go back to. They don't need to teach niche skills. They don't need to try to chase after the latest trend and the latest technology. When you're teaching software fundamentals, the fundamentals of development and the best practices are easy to keep up with because those are not consistently evolving. But trying to teach the latest programming language or keeping up with platforms and trying to update your curriculum every 2 months, 1 month to try to chase down it's not the way that they were designed. But they were designed to add to bodies of knowledge. And I think that's where we need to get back to.
Yeah. So I think we are kind of like taking more time than like we originally planned. But maybe like we can quickly go through, like there are a couple of questions that we still haven't answered. Maybe we can try to quickly answer them before wrapping up. So do you think machine learning product managers need an MBA or not?
No.
No.
No, degree doesn't matter. I did it. I got an MBA with an econ focus to try to figure out business. Like I did a business when I was very, very young. When I was going through college, I made every mistake possible. Went into the corporate world trying to understand what I did wrong. Came out of the corporate world more confused than I started. I did an MBA because I was trying to understand how business thought and worked. And no, you don't need it to be a product manager.
And unrelated question. How soon we will see data science role being split into multiple different roles, more specific?
It's happening now.
It's
It's
happening,
very
like
much
machine
happening
learning
right now.
engineer, these roles we talked about, like this researcher.
And I think more. I think we're going to see things like a model quality assurance engineering and engineering, quality assurance groups starting to come up. So if you look at software development, that's going to be the paradigm for model development. Research is going to be something totally different. Like if you look at biotech or pharma, they manage research. They have researchers. They have learned how to monetize research. They manage the research process. And so that's where the new roles within companies and new capabilities are going to be going towards and being focused on. But your traditional data science, what we call a data scientist now, is going to follow more of that software development, software best practices paradigm.
Yeah, makes sense. So you said that angry users are important. So what kind of metrics we need to use to measure their angriness or whatever they like the satisfaction of these users?
That's a good question. Adoption. Adoption is one of the easiest metrics to follow because if you're creating a new product, if you're creating and defining a new category, it's really adoption. Who's using it? How long are they using it? How long does it take them to complete a task that they used to do either manually or they did with another solution? What's the learning curve? How long does it take to get a user from novice, never seen it before, to an expert power user? Once you get to a power user, how long does it take on task? How much time does it take per task to complete work? Have you reduced the total number of tasks that person has to manually interact with? Are there fewer tasks in their chain? And then in my domain, do a lot of decision support. So, what are decision outcomes? What is the decision chain that leads to a particular outcome? What information are they consuming in order to make that decision? And how do we improve what information we are giving them to drive better decision outcomes? And then that feedback loop, measuring the quality of decision. You have 100 over 100 being the perfect decision. Now, what score did this particular decision result in? If you have a product with a revenue range, for example, you have your top, you have your expected, and you have your underperform. You have a decision chain that leads to that product being deployed, being adopted, and being monetized. How are your pricing decisions? Were your pricing decisions correct to achieve your at least baseline or overperform? Or did they underperform? What data did we use in order to make those pricing decisions? And then what data can we change? What data can we improve in order to help the next project perform better, to get more to that mid or high end of the projected revenue or cost savings range? And so those are really tangible metrics when it comes to adoption and when it comes to building these solutions that we need to start focusing on.
And they're not necessarily related to machine learning. So these are, I would say, usual product management, like product metrics, right? So this is something that a usual product manager would care about, and right. So
Yeah,
they're
it's
then
defining an entirely new way of connecting model output,
this is what they do.
your prediction and model quality back to an actual hard number, because there needs to be a hard number on the other side where you've mapped, here are my model metrics, and if I can improve a particular piece of performance, that results in this happening on the business side, this happening on the revenue or cost saving side.
Okay. Yeah, I think that's all. So it's already, you can see that it's already dark. So it's, yeah. Okay, thanks a lot. Thanks a lot for coming, for sharing. I wanted to ask you so much more than I did, but we had a very interesting discussion and I learned a lot from you. So thanks for coming. And I'm sure that the 33 people who are still there, they also learn a lot. So that's why they stayed, because the information was invaluable. And it was also interesting to hear your thoughts about like the education and like how we can change that. So thanks a lot for coming. And
Thank you for having me. I really appreciate it.
yes,
Thanks for all the time you put into it. And thanks everybody who stuck around for just over an hour's worth of me talking.
yeah, but like they actually, this, so now it's 5:20 p.m. and we started at noon. So actually like I don't know if all these 33 people started at noon together with me, but yeah, it's been a while. Okay, so I'm not taking your time anymore. Thanks a lot for coming.
Thank
And
you.
yes, so we will chunk this long video for like 4 or 5 hours video into multiple things. This conversation we will upload also as a podcast. And yeah, thanks a lot for coming. And next week we have another day of the conference where we will talk about machine learning in production. So thanks, Vin.
All right. Bye.
Goodbye.